If you're trying to become a DevOps engineer in 2026, the biggest mistake beginners make is learning tools in the wrong order. They start off with Kubernetes and Terraform without understanding the foundational concepts. In this video, I'll walk you through the 2026 DevOps roadmap that I would follow if I were to start from zero. Before we jump into the roadmap, let's quickly understand what DevOps actually means. DevOps is a combination of development and operations that focuses on managing infrastructure, automating software delivery, and ensuring the applications run reliably in production. A DevOps engineer typically works with containers, infrastructure, automation tools, and CI/CD pipelines. You should start by understanding the Linux fundamentals, followed by networking fundamentals. These are the basic concepts one should be aware of. After that, you'll proceed with scripting language, a version control system, containers, CI/CD, cloud, infrastructure management, container orchestration, and finally, monitoring. We shall dive a bit more deeper into the concepts shown in the DevOps roadmap earlier. Let's start with Linux, which is foundation of almost everything in DevOps. Most servers in the real world, whether it's cloud, containers, or Kubernetes, they run on Linux. So being comfortable with Linux is absolutely essential. When I say Linux fundamentals, I'm talking about things like navigating the file system, understanding permissions, managing processes, and working through the terminal. For example, you should know basic commands like listing files, moving between directories, or checking running processes. These are the things that you will use daily as a DevOps engineer. The commands could include mv, ls, and so on. Another important aspect is SSH, which allows you to connect to remote servers securely. In real world scenarios, you will rarely interact with servers through a UI. You'll be connecting with via SSH and working directly in the terminal. Then you have virtualization. Of course, there are text editors as well. VIM is one of the popular one, but there are plenty more. You should also be familiar with package management, which includes installing software, updating dependencies, and basic process management like starting or stopping services. Package management is done via various package managers like apt, yum, for instance. The type of package manager you use depends on the type of the Linux distribution you are using. The goal here is not to become a Linux expert immediately, but to feel comfortable working in a terminal environment. Once you're comfortable with Linux, the next important piece is networking. DevOps is heavily dependent on distributed systems, and all of these systems communicate over networks. So, understanding how networking works is critical. At a basic level, you should understand concepts like IP addresses, both IPv4, IPv6, how machines identify each other, and how communications happen over the internet. Then you have CIDR ranges. The number of IPs included in a CIDR range will vary, and how you calculate this and everything will be explained in future videos. You should also know what ports and protocols are. For example, HTTP runs on port 80, HTTPS runs on port 443, and these define how data is transmitted between systems. Another key concept is network services like DHCP or DNS. When you type a domain name like google.com, DNS translates that into an IP address like 8.8.8, so your system can connect to the correct server. Even a basic understanding of routing and how requests travel across networks will go a long way in debugging real world issues. Suppose you have written the code for your application, you need to version it. How is that achieved? This is via Git. This is the backbone of collaboration in modern software development. In DevOps, everything is version control, not just code, but even your infrastructure and configurations. You should understand basic concepts like commits, branches, merging, etc. Branching allows multiple developers to work on features independently, and merging combines those changes. You'll work with platforms like GitHub, GitLab, and so on, which act as collaboration layers on top of Git. You might ask, what's the difference between Git and GitHub, GitLab? Assume Git is your engine of the car, and GitHub, GitLab are nothing but the vehicles. So when you write code, that's versioned locally on your local machine. But suppose you want to share that code with your teammates, how are you going to do that? That's via GitHub and GitLab. Let's look at a sample GitHub repository called deployment tracker. This is how the code structure looks like. And you have multiple branches as well. You have a main branch and a feature branch. You can also see GitHub Actions, which is used for CI/CD pipelines, pull requests, and so on. In real world DevOps workflows, every change typically starts with a Git commit and flows through a pipeline. Once you understand Git, the next step is containers. Containers solve a very common problem. It works on my machine, but not in production. Tools like Docker allow you to package your application along with its dependencies, so it runs consistently everywhere. You should understand the difference between images and containers and basic commands like pulling an image or running a container. Containers are nothing but building blocks for modern deployment systems. You package your application code into images and then run them in containers, which provide the isolation. You store the images in image repositories or registries, for instance, Docker registry. For example, this is how Docker registry looks like. You can see various images pushed here. You can download the image and just use them in your containers. Now that you have packaged your code, you need to deploy them and automate this process. That's where CI/CD comes into picture. CI stands for continuous integration and CD stands for continuous deployment or delivery. The idea is to automate the entire process from writing the code to deploying into production. For example, when a developer pushes the code to Git, a pipeline can automatically run tests, build the application, and deploy it. Tools like Jenkins, GitHub Actions, GitLab, CI, they help automate this workflow. This is where DevOps really starts bringing efficiency into your software lifecycle. You can also use Argo CD for your continuous deployment or delivery. For example, let's look at one of the CI/CD pipelines via GitHub Actions. If I click on this, you can see that there are different phases or jobs: build, test, Helmland. Build would in turn consist of various steps like setup job, install Go, and so on. So far, we have been discussing about deployment on-prem, but next comes cloud platforms like AWS, Azure, or GCP. Instead of managing these physical servers, we now use cloud providers to provision infrastructure on demand. You should understand core services like compute, storage, and networking. For example, in AWS, services like EC2 provide virtual machines, S3 provides storage, and VPC handles networking. Cloud platforms are the backbone of modern DevOps environments. Suppose you want to create a EC2 instance, you would just go onto the Amazon console and create it manually via the UI. You can do it once, but not for hundreds of servers. That's where infrastructure as code comes into picture. There are various tools like Terraform, Pulumi, which enables this. Tools like Terraform allow you to define your infrastructure using code instead of manually creating resources. For example, instead of clicking buttons in your cloud console, you write a configuration file that defines servers, networks, databases, etc. This makes infrastructure reproducible, version control, and automated. Now that you have hundreds of EC2 instances provisioned, how are you going to configure them? Again, you can't do it one by one manually. You can automate it via Ansible. Ansible is one of the configuration management tools that can be used to configure EC2 instances or other services. We have seen how to package code into images, run as containers, and deploy them. But what if there are hundreds of containers running? How are you going to manage them? This can be done via container orchestration tools such as Kubernetes, OpenShift, etc. Let's look into Kubernetes. When you have multiple containers running across different machines, Kubernetes helps manage them, handling scaling, load balancing, and availability. You'll work with concepts like pods, deployments, services, and so on. Kubernetes is widely used in production systems, so understanding it is a key milestone in your DevOps journey. Let's move on to the next stage. Now that everything is running in production, how would you know if something breaks? Or whom are you going to notify when something breaks? And that's why we need monitoring and observability. This helps us understand how systems are performing and detect issues early. Tools like Prometheus collects metrics, Grafana helps visualize them, and tools like Eager help with tracing. Monitoring ensures your systems remain reliable and performant. Once you have mastered all of these, and if you fancy more, there's advanced DevOps, platform engineering, and SRE concepts. What's the difference between three of these? I'm going to explain them in future videos. But these include DevSecOps, security scanning, artifact repositories, registries, service meshes, and so on. One more mistake beginners make is trying to learn everything at once. It's pretty much tough. I did the same mistake. Rather, focus on one section, master it, and then move on to the next. If you're starting your DevOps journey, This roadmap should give you a clear direction. In the future videos, I'll break down each section with practical examples. If you like this video, comment and subscribe for more DevOps tutorials.